Okay, so last time we looked at completing the square, and we saw that while for solving equations it might be a tad slower than factorizing, the advantage is it works all the time for any quadratic ever. The other nice thing is that the process is essentially the same every single time, which means we can apply it to a general quadratic. So here a, b, and c stand for any constant number, and the result will be a formula that solves any quadratic equation for us straight away, which is pretty exciting. Okay, so the road there, though, will be a little bit messy. Our first step will be to get rid of the a in front of the x square so we can start doing the complete the square process. So let's divide everything by a. Okay, the right-hand side will still be 0, of course, but on the left, we have b becoming b over a, and c becoming c over a. So we look to complete the square, so preparing to slide in that green number, which we know comes from taking the middle number, the b over a, halving it, so b over 2a, and then squaring it, so we square everything and get b squared over 4a squared. We of course need to subtract it then, and that gives us this perfect square here. And actually this time the more annoying part is the constant, okay, because it's a fraction addition subtraction thingy, so he's going to need a common denominator, and it would be sensible, I think, to aim for 4a squared as that common denominator. So when we bring that across, you'll notice that for c over a, we've actually multiplied top and bottom by 4a, so that the bottom will be 4a squared as well. Okay, so we should gather the constants to the right-hand side. We will have this denominator of 4a squared, so the negative b squared ends up being positive, and the positive 4ac ends up being negative when you bring it all to the other side. Now we want to kill the square by taking square roots. The bottom is easy because square root of 4 is 2, and the a just loses his square. Different story for the top, though. He's going to copper plus or minus square root, but now we want to subtract the b over 2a. Thank goodness the bottom numbers match already. Okay, so that means to finish this, we just subtract the b across to join the fraction, and the result of that is the quadratic formula. Okay, before we do a quick example though, let's make sure we're clear on what's happened, because there's heaps of symbols and it's easy to get your head in a mess with so many different letters everywhere. So we started with any quadratic equation where a and b and c are just constant numbers, but they could be anything. Okay, and what exactly are these numbers doing? Well, a must be the guy in front of x squared, b must be the guy in front of the single x, c must be the constant number by himself with no x's. Note there must be an equals 0 on the other side as well. That's been a common theme throughout this topic, and it is still to be the case here. Then the formula solves this for x, so it tells you what x equals. Okay, that would solve that equation, and it looks like this beast here. Okay, so let's try it. Let's use it to solve this equation here. Get in the habit of at least trying to factorize first, but we'll give up on this one quite quickly. Okay, so we'll use the formula for this. X is going to be a massive fraction. It starts with negative b, but what's b? Well, b is the number in front of the single copy of x, which is negative 2. So negative b must be positive 2. Then it's plus or minus a huge root. And next inside that root is b squared. So negative 2 or square. And if you're going to use a calculator, make sure you bracket it. It's a very common mistake to miss this bracket around the negative, like this one in particular, okay? So don't forget that. Alright, then it's minus 4ac, where a is the number in front of x squared, so 3, and c is the number by itself, so negative 7. Again, a negative that I find is commonly missed too, but not as much as the other one, okay? But still look out for it. The bottom is just 2a, which would be 2 times 3, so now we can just clean up all the numbers. First, the bottom is easy. 2 times 3 is 6. Then inside the root, I would just use a calculator most of the time. We would get 88 here, we can actually simplify this if we remember how to work with surds. So everything else not surdy will keep the same for now. We should recognize that root 88 is just root 22 times root 4, but root 4 is just a regular 2. And so that gives us a final step, which is to halve everything in this fraction to simplify it. So all the 2's upstairs become 1's and 6 becomes 3, and now we are all fully simplified and finished with those two answers. So this is a formula that will solve any and every quadratic straight away. But as you can see, it is a little bit fiddly, okay? And it's easy to mess things up like negatives and stuff. It's not all that fast. So my general approach and how I suggest you do these as well in the wild is give yourself, say, I don't know, 5-10 seconds. That's what I normally do, okay, to factorize it in your head. But if you can't get it in like 10 seconds, I'd cut my losses and just use the formula then, okay? So that's all for this one. Thanks for watching. See you around.